adapting of the series. And we had these basic series, but we did see a couple of mistakes, right? We said that was a 4, and that guy was a 1. So we saw those 2 mistakes on that. And these are ones that we have to have memorized. Look at them one more time, get them down in your brain, or in your thought. E's are all positive, and they get all the powers with factorials. Cosines and sines alternate. Sines are the what powers? Odd. Cosines are the evens, starting though at 0. ln is the only one that doesn't have the factorials, but it also alternates. And then we said this one right here is easier to think of a geometric and then write it out. Okay? And if you really want to memorize that one, great. Okay, so those are ones we have to know. So we adapted this first one. We said the easiest way to do this was to start at the what? Start at e to the x, then plug in the 3x. This guy, we said the easiest one was to start at cosine, then plug in the 4x. This one, we had to switch, we said, and we did that, right? But this one, it was centered at 0. We wanted the Taylor polynomial. We said the easiest way was to start at sine and then plug in the 3x. So we were on this one here when we stopped yesterday. So it says, prove that the Maclaurin series for the function converges to the function. And we got through, we started with e to the x, and then we plugged in that negative 2x, right? So everywhere we saw an x, we plugged in the negative 2x. And we wrote our series. And that's where we ended, I think. Okay. One thing I wanted you to see here, though, before we move on to what we're going to do for that second part, is when we plug this guy in, what happens when the powers are odd and you plug in a negative? It stays negative. But what happens when the powers are even and I plug in a negative? It becomes a positive, right? So I can basically square that negative and bring it out. What's the next one going to be? A negative. What's the next one going to be? Positive. Because, again, with that to the 4th, a negative to the 4th is just a positive. So I could see this with the alternating part out in front, which, again, a lot of times, do we want to separate those? Yeah, we want to get like the coefficient part out front. So I could have this as like the negative 2x out in front. Or I could even see this as the negative 1 out in front, the 2x involved, right? So there's lots of ways that we could see this series. And that's, again, we just have to recognize that all of these guys are equivalent. Okay. That being said, let's go back now to what it's asking us to do. It says prove that the Maclaurin series for the function, so it says prove that this guy, right, converges to this guy for all x. So they're saying show that this polynomial here, as you expand it out, is going to be the same as this exponential. Everywhere. Because you keep going on that exponential, it's going to continue and continue to match for negative infinity to infinity. That's kind of really cool. Well, how could we show that? The ratio test. And if you recall, when we did the ratio test, just to do a little side note, when we did the ratio test, if the limit of that guy equaled 0, what did I know? Converges what? Yeah, converges for all x. x from negative infinity to infinity. If that limit equaled infinity, so that's option 1, that's option 2. If that limit equaled infinity, what happened? Does it diverge everywhere? No. It's everywhere but where you're centered. So it's only going to converge at that center. And then the third option that we had is when we got it to equal something like this, or something like this, right? I don't know, something with an x value out. And then when we got it like that, that's when we go find the interval. And what do we do at the endpoints? Check endpoints. Okay. So just the little side note of the 3 things that we have seen that could happen. Well, this one is wanting me to show that it converges for all x, converges everywhere. So what's going to have to happen when I do the ratio test? The limit's going to have to equal 0. Let's see if that is the case. Go for it. Do your ratio test. We're doing the ratio test for this series, which is that right there. What happens with the whole negative part when I include my opposite values? And I just drop them? See how you did with your ratio test. Everybody good? A sub n plus 1 over a sub n to cancel out, okay? So then our limit was 0, which is what we hoped. So when the limit is 0, I can say that, hey, this guy right here converges, right? So this guy right here for all, okay, let's get fancy, for all x. That's pretty cool. Not just everywhere. Does that make sense what this is telling you? Okay. Yes.
So upside down A and the X means
This means this is the symbol for all. So it means for all x. Yeah, just a math notation. Okay, any more questions on this one? Okay, so we're gonna have a little bit of fun. So let's look at this one. And it wants us to multiply together each of the x times cosine of x. Well, tell me, write out the first few terms of e to the x go. Go like 5 or 6 terms. Just be able to do that fairly quickly now. That would be have this one down. Good? Okay, do the same thing for cosine x. Give me the first few terms. We're going to go with those two. Okay, so those are basics. We start with our basic, always on these manipulation ones. Now it wants me to multiply. So it's asking me to say, it's saying multiply these two guys, which is basically saying take this guy and multiply it by this guy. So I've got out this huge boiling problem. You see that? Okay. The easiest way to do this, and I taught like, when you learn Algebra 2 and you just don't have binomials, then some of your teachers may have shown you this table. Okay, it's so much easier to keep it organized if you kind of write out your terms in a table. So like here is my e to the x, and then I'm going to put my terms of cosine over here. Okay, and I probably have way more terms that I'm going to need to multiply out. I'm just going to kind of leave my options open in case I need to do more. Now, sometimes they'll tell you what degree to stop at, and that's really, really nice. This one, however, said I just need to find the first 4 non-zero terms. So I'm not sure what degree I need to stop at as I'm multiplying. I'm going to wait for you guys to get your tables set up. And then it's nice if you kind of use a different color on the inside or just make this line really, really thick so you know that you're not including those are not terms. Okay? Going on. And let's fill it in. So we're just going to multiply into these squares. So 1 times 1 is 1. 1 times x. And I could keep going out to the 5th if I really wanted to. Okay, so that goes out to the 5th degree. I'm not sure how many things might cancel to 0. Let's do this next one. You all see what I'm doing here? Okay, so then times the x. And I'm going to wait here. I'm not going to go farther than a 5th degree. If I need to go and write more terms later, I will. I'm thinking that I'm not going to have that many things cancel out. Who knows? And this next one wouldn't be a 5th degree, it'd be a 6. So I'm going to hold off. So do you see how I've gotten all the 5th degrees and lower that are multiplied so far? That's to write this e to the x cosine x, right? So we're going to get our first non-zero term with all of our constants. So the first term is 1. Then we're going to get our degrees of 1. Well, x is the only one. So far so good. I've got 2 non-zero terms. Then I'm going to get all my powers of 2. Wah, 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 wah. What happens there? They canceled. Okay. Oh, we may have to go out more because those guys canceled. Then I'm going to get all my powers of 3. This one, and this one. Oops, just kidding, just kidding. That's a 4. Okay. So those 2. And I see that they're not going to cancel, but I'm just going to do some scratch work and say, hey, what's negative a half plus a 6? I just kind of can do it over here on the side, right? And what do I get out? Negative 1/3. So I have negative 1/3 x cubed. Okay. And then I'm going to take the powers of 4. So that one, that one, that one. Again, I'm going to do the 1/24 minus 1/4 plus 1/24. And you guys all do that out. You can practice your fractions. X to the 4th. Now, was x to the 5th even too many things that I had to go out? Yeah, okay. And let's say that stuff started canceling. Could I go find all the 6 powers pretty easily, though? Sure. Okay. So, this is a way that organizes and makes life a little bit easier. That's your answer. All right. We are going to look at this part C. Write the first 4 non-zero terms of the Lorentz series for e to the x. Go. 30 seconds. We got it? That's 30 seconds. Okay, so there's my first 4 non-zero terms for e to the x. First point gained out of 9. How easy was that? To get that 1 point. And do you see how you don't even need A and B for C? So even if you're like, what? You can still get points. Every free response is 9. Okay. Then it says, use the Maclaurin series for e to the x to write the 3rd degree Taylor polynomial for g of x. And g of x is e to the x times f of x. Oh, hold on. Well, I got e to the x. What was f of x again?
X minus 3 over 2 x squared plus 3x cubed.
Right? So there was that. But it told me I could stop where? 3rd degree. as I start multiplying these? No. So I can stop here. Go. If you wanted to write out more terms, power to you. But your final answer is just the third degree. Not 3 non-zero terms, but just the third degree. So after an x cubed, you stop regardless of how many terms you have. So we're doing exactly what we just did. We're going to set up our table. So we just did on the previous problem. See if you get that for your final answer. So anytime you're multiplying, if that degree is going to be bigger than 3, do you have to even write it down? No. So this was nice to us. It didn't say like that we were going to have to cancel any of these. Yeah, so all of those, yeah. Not that it said right in the first word, not the other terms. We might have to do more like that. But now we can cancel out all the 4s, right? Yeah. Is it only one of those? Oh, was that your original? Oh, sorry. Yeah. Okay.
Good.
So I got 2x cubed. So it's 1/2 minus 2/2 plus 3. Do you need me to fill this in?
Well, well.
Is that good now? Okay. And you guys can see this was an AP question either from last year or the year before. Okay. So I'm so glad I made you multiply together. No, it's just a great technique. Multiply. Otherwise, you'd be like, distribute, distribute, it just so much more efficient. Let's go ahead and do A and B with your group on this one. about him here. So I know that this guy converges when I'm less than 1. But remember, I'm trying to get it in the form x minus c is less than my r. But I'm centered at 0, so I need to get rid of that 3 out front. So what is my r? Huh? 1/3. Is that okay? So that was a pretty basic one to just have to do the ratio test. Those are the ones you should not miss points on because they are just the procedural points. Okay? Okay, B. Write the first 4 non-zero terms in the Maclaurin series for f prime. Go. You actually have 2 options. They gave it to you term by term, and they gave it to you in a series. So you could do the derivative of the series and then write out the terms. Or you could go term by term. You get to pick on this one. Okay? So if I do term by term, I'm probably going to need to go out 1 more. So this was 1, this was at 2, this was at 3. No. What happened at 1? No, that was at the 1. Yeah, that was right. 2. At the 3. Okay. So then they didn't give me that next term. That would have been 3, let's see, negative 3 to the what? Third. X to the 4th over 4. Yes? Okay, so it wants the first 4 non-zero terms of f prime. So f prime, derivative of that guy is 1. Derivative of that guy is negative 3x. Derivative of that guy, what? Derivative of the next one, okay? So here I can see there's my first 4 non-zero terms. What is that going to be, though? That's going to help me out if I can see what that's going to end up being. Whenever I see this rational expression, what kind of test is popping into my mind? What's that? Geometric. Okay, when I see this rational expression, I'm thinking geometric, a over 1 minus r. Okay, as soon as I see that, that's what's popping into my mind. So I'm trying to figure out what's my a and what's my r here. Does that make sense? So if I'm going to see this, what was my a? What was my first term? 1. And then what am I multiplying by every time for my r? Negative 3x. There's my r value. Can you see that? Does that work? Plug in 0, plug in 1, plug in 2. So can you write this as a rational expression now? Okay, go for it. Okay, any questions on this one? So we're gonna look at this guy. For some reason, I think I put it in after we'd already done the notes. Okay. So all you need to do though is write this down somewhere where you have some blank space. Okay. On that 810 part. And let's do it together. Or maybe on the back of your notes, because we're going to do a couple on the very back of your notes too. Okay, so that's you. So just write down this one right here. And whenever we see these really crazy ones, I got a sign, T to the 6, I got some inspiration, okay, we always start with the what? The very well, yeah, but like when we were doing all of these, so think back to what we had said. What do we start with here? Which was e to the x. What do we start with here? Cosine. What do we start with here? Sine. Okay, so as I'm doing these, what should I start with here? Okay, so let's start with sine. Start with the one you know. Write out the first few terms. No, just write out the terms of sine. Like the basic one. You know what I'm talking about? Grant, what do I do next? Yeah. Good. Very good. Just wait. And then after I have that, what do I finally get to do? Integrate from 0 to x. So now I can take the antiderivative, plug in 0, minus the antiderivative, or sorry, antiderivative plug in x, minus the antiderivative plugged in at 0. So this would be t to the 7th over 7 minus t to the 19 over 19 times 3 factorial. Can I show what I just said? So I said we're going to take the antiderivative evaluated at the x minus the antiderivative evaluated at the 0. The fundamental theorem of calculus. And again, we're going to evaluate that from 0 to x. So as I do that, when I plug in my x, that's not too bad. So there's that x minus, when I plug in my 0, what happens? It's just 0. So I just get this guy out, basically. So what's my answer? D. Who wants to try to write that? No, thank you. first few terms, right? Okay. So again, an AP question. Start with the basic, then move forward. Okay. So we're going to do a couple more AP problems that involve the manipulation that I really, really like. Okay? It's going to be manipulated even a little bit differently than what you've seen. So if you want to go to the back of your notes or somewhere where you have a blank spot to put those on. So we're first going to do the 2010 test. So if you want to write down what it's from, this is the 2010. Okay. You guys should make the first sentence of part A in 30 seconds. Go. Really make it. First, okay, all good for that? Yes, because it asks you to do the general term. Okay, so that is the general term right there. And that's how you would write it. Did it ask you to write the whole summation or the series? No. So I don't want to see the summation symbol for this part. Okay, now whatever would be in here, what that would equal, that's going to be the same thing as what you see there. Yes? So the general term is just the same as what goes into the series, but it's just written as the general term like that. Okay? Okay. So now let's look at the next part. Use the series to write the first 3 non-zero terms in the general term for the Taylor series for F. Now, they've made it all tricky, but you're just going to take this part for F. Okay? So what they're going to do is they're going to say, hey, you know what cosine is. Plug that, oops, I gotta change my color. Plug that cosine in for cosine, right? So that's going to be that cosine. We plug those in. Then we're going to do what? Subtract 1. How many times do I subtract 1? Is it for each term? It just says minus 1. So you only do this once, and this is where kiddos get confused. They try to subtract 1 here, subtract 1 here, subtract 1 here. But that's not what it says. It says take that whole thing and then just subtract 1. So basically when I subtract 1, what did it just knock off? That. Right? Then it says go and do what? Divide everything through by x squared. So that's kind of my steps that I'm taking. I look at the cosine, I just subtract 1 off, and then everything gets divided through x squared. Do you think you could write the first three non-zero terms and the general term? Can you try? So start writing out what you see and then write the pattern. It is in this case. It's all of it divided by x squared. So we only do this guy 1. Just subtract 1. And then everything gets divided through by x squared. So that kind of looks like that. You can take off the 1. Make sense? Okay. How many do I have to do? 3? Now we got to try to write this general term. Is it alternating? I know I'm going to have the negative 1. So when I plug in my 0, though, does it match?
No.
So I need to do an n
Plus.
plus 1 or an n minus 1. Either. Yes. Okay. Then I'm going to have my x to the what? 2n stuff. Does that work? 0, 0 power 1, first or second power 2, fourth power. So that works. Over, I know I'm going to have something factorial. What's the slope? 2, 4, 6. And I know I have 2n. Does that match that? So what do I have to do on the inside here? Add 2. Now does it match? Yes. No. So this one and this one canceled each other out. So I just have this guy left to be divided by the x squared. And that's what I was kind of showing here. Okay. Okay. We're going to look at another one. Oops. So this is going to be the 2009 test. And I want to see, you guys should be able to do part A without much of a problem. They gave you easy x, which you're kind of like, okay, thanks, but then you're kind of like, dang it, I wanted to get those points. Easy points. So they gave you e to the x, and they want you to find e to the x minus 1 quantity squared. Go. First 4 non-zero terms and general term. I see an x, what am I plugging in? Minus 1 quantity squared. So not too bad. Those are the easy points. Are we good with that? Now, I know they're not easy problems, but comparatively, you know, when I say that, I'm not trying to simplify. Yeah. Oh yeah, what happened there? I know, I think I wrote it. Okay, thank you, Princess. Thank you. Okay, now are we good? Alright, so that's part A. Great. Now B says, use what you just did, and now do the first 4 non-zero terms and the general term for F. So now here is my F. Go. It's very similar to what we just did. Are you good? Okay. So I subtract 1, which tells me that goes away. I subtract the 1. Yeah. Okay. I know, that was a big one. Alright, so then I have to divide everything through by the x minus 1 squared. Basically, right? So that's going to equal 1 plus x minus 1 squared over 2 plus x minus 1 to the 4th over 6 plus dot 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 plus, and you could make that 2n minus 2, or you could just say x minus 1 squared n factorial. Okay, so if you were only to put together, you could make that x minus 1 to the 2n minus 2, or you could just leave it being divided. Where? 2. No. 6 minus 2. No, when you do, if you like had a to the 6 over a to the 2. Yeah. Yeah, so if it was this, that's what you're saying. Then you divide. So again, not too bad. Yes? Well, the one now, this one actually came from this right here. So that's where that one came from now. So this one went away from this one.